Hi, my name is Sarah and this is my robotic hand project. I built this prototype as a personal challenge and as a way to explore the robotic prosthetics field, an area I'm deeply interested in within biomedical engineering. This project allowed me to combine different fields such as mechanics, electronics, and design to create something meaningful and functional. The hand works using a tendon-driven system. Each finger has a string that acts as a tendon, which is pulled by a servo motor to flex the finger. At the same time, a series of elastic bands are used to return the fingers to their original position. Through this mechanism, basic finger movements such as opening and closing can be replicated. I started the project by designing and 3D printing a single finger in SolidWorks. This first prototype helped me identify several design issues. One of the main problems was that the holes for inserting the elastics were too small, which limited the use of more resistant elastic materials. In addition, the surfaces were too perpendicular, causing the finger movement to feel stiff and unnatural. Even though the concept worked and the finger movement could be replicated, it was clear that the design needed improvement. I redesigned the finger by increasing the size of the holes, adding a margin for the elastics, and smoothing the edges of the joints. I also switched to more resistant elastics to improve durability and control. These changes made a noticeable difference, resulting in a smoother and more natural finger movement. Once the finger design was working properly, I moved on to assembling the full hand. Each finger was designed with slightly different dimensions to better match real human hand proportions. After testing the full assembly, the final version of the hand was 3D printed and mounted onto a forearm structure made from recycled plastic. The hand is controlled using an Arduino and servo motors, which allow it to open and close, and move each finger individually. This setup provided precise control while keeping the system relatively simple. Here, you can see how the servo motors pull the tendons to flex the fingers, while the elastics return them to their resting position. Looking ahead, I would like to enhance this project by enabling it to recognize hand gestures or finger movements. This can be done using flex sensors or even EMG sensors. This will bring this project closer into a real prosthetic hand. Overall, more than just a technical challenge, this project was my first introduction into biomedical engineering. It showed me how demanding yet fascinating this field can be, and it strengthened my motivation to keep exploring this world, where engineering, biology, mechanics, and electronics can merge together to improve health and to improve the quality of life of people.